Hello again, welcome to another lesson in geometry. Today we are covering section 12-3, inscribed angles. So we have some vocabulary first. We're going to write noun or verb to identify how intercept is used in each one of these sentences. So the defense tries to intercept a touchdown pass. Intercept in this case is the action of them taking the ball in the air, so that would be verb. The y-intercept of a line is the y value at x equals 0. So the y-intercept is a noun. That's the subject of our sentence. Cryptographers intercept and decipher code messages. So intercept is one of our verbs here. They intercept and they decipher. Those are the actions. The x-intercept of a line is the x value at y equals 0. So this is once again a noun, just like above. So we have some vocabulary builder here. We have a new word called inscribed. Related word are circumscribed. So this angle over here is an inscribed angle inside of the circle. Okay, we saw this before when we had circles inscribed inside of triangles and inside of polygons back in chapters 10 and 11. Okay. All right, so our definition is inscribed means written, marked, or engraved on, and circumscribed means encircled, confined, or limited. So an inscribed angle is formed by two chords with a vertex on the circle. So we have two chords and they have a shared endpoint on the circle, okay, and then they make an inscribed angle. So the angle formed is this angle. Write circumscribed or inscribed to describe each angle. So our first one looks just like the picture above. So this is an inscribed angle. The second one is a circumscribed angle. Circumscribed. Try that again. Okay, so is the number 7. So this is circumscribed. And the last one is inscribed. So inscribed, the angle is inscribed inside of the circle in this case, and the circumscribed, the circle is inscribed inside the angle, or the angle is circumscribes the circle, so it's outside of the circle. All right, so underline the correct word to complete each sentence. Angle ABC with points A, B, and C on a circle is a, which one is it going to be? Circle, circumscribed, or inscribed? So let's try to draw that. Okay, so all points A, B, and C are on the circle. And there's our angle, so that's definitely going to be inscribed. Okay. An intercepted arc is between the sides of a circumscribed or inscribed angle. Okay. So let's see. Here is our arc. Okay. And this one, the intercepted arc is between the sides of a circumscribed or inscribed angle. So here is an angle, and the intercepted arc is in between them. Theorem 12-11, inscribed angle theorem. So the measure of an inscribed angle is half the measure of its intercepted arc. So in this picture here, the measure of angle B, which is right here, is going to be half of the measure of the arc that it intercepts. So it intercepts this arc AC here. Okay. So if we know this number, we can just cut it in half to get that one. Or if we know this one over here, we can double it to get the arc. Okay. So in our problem here, we have suppose the measure of arc AC is 90. Then we know the measure of angle B is going to be 1/2 times the measure of the arc, and 1/2 of 90 will give us 45. And suppose the measure of angle B was 60. Then the arc is going to be equal to twice the measure of angle B. So 2 times 60 will give us 120. All right, so I have a geometric sketch pad to kind of display this to make it stick in your brain a bit more. All right, so here is the arc AB, and we have angle C over here. And notice no matter where I put C, the arc doesn't change and the angle doesn't change. So the arc will stay 53.98 and the angle will stay half as much as that. Okay, then if I pick up A here and slide it to make my arc bigger, no matter how big I make it, the measure of angle C will always be 43, half as big. So since this was 86.54, 43.27 is half as much. And once again, I can move C around. It doesn't change, okay? So it doesn't, no matter where I put the inscribed angle, it'll always be half as big as the arc. All right, now, what if I put A so that it's exactly on the diameter? So now this guy is supposed to be an arc of 180. It's a little hard to get it exactly 180, so I got 180.11. Notice that C will always be 90, okay, or about 90 in our case. So if you have an arc that is a semicircle, okay, then the inscribed angle will always be a right angle because it'll always be half of the arc, and the arc was 180. All right, let's go back and look at a couple more problems on this. So using the inscribed angle theorem, complete the reasoning model below. So I know that the sides of angle A are chords here. So here's my angle A. So it looks like that. And they're both chords for the sides. And I can use the inscribed theorem to help me find what the angle A is. So angle A is an inscribed angle. And the measure of angle A is going to be half the measure of the blue arc. And because the line here that makes up the other side of that triangle there is the diameter of my circle, then my arc is exactly 180. So this is going to be a right angle, half as much. So the measure of the blue arc is 180. And then the measure of angle A is going to be 90. All right, so we have some corollaries that come off of the inscribed angle theorem. So two inscribed angles that intercepts the same arc are congruent, and we showed that when we slid it around. So remember, we could have picked up A here and moved it around to where B was, and they would match, okay? And then we have corollary number two. If the inscribed angle is for an arc that is the semicircle of the right of the circle, then we know that the inscribed angle will be a right angle. And then corollary 3 says the opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay, so let's think about that one for a second. If I look at angle D and I look at angle B, angle B uses up this much of the circle, okay, for that arc. So it's going to be half as much as that. And angle D is going to be with this arc here. Now notice the red and green arc. So so angle D will be half as much as the green arc's measure. Now notice the red and green arc together, these two arcs added up, make 360. So if I cut that in half, together these two should be half of 360, which is 180. And that's what supplementary means, two angles that add up to 180. All right, so use a diagram at the right to write true or false. So angle P and angle Q intercept the same arc. So let's take a look at it. Angle P is here, and angle Q is here. This one uses the arc formed by T and R. And angle Q uses the arc formed by T and R also. So this is going to be true. Angle SRP and angle Q are the same, intercept the same arc. Let's see. So we'll erase here. SRP. Okay, so SRP is this angle, which corresponds to this arc. Okay. And Q is this angle, which corresponds to this arc. So this is going to be false. The arcs overlap, but they're not the same. TSR, so arc TSR is a semicircle. Let's see. So TSR, now that's definitely going to be a semicircle because the endpoints of the arc are touching a diameter of our circle. So let's cut that circle in half. So this is going to be true. Angle PTS and angle SRQ are opposite angles. So let's see. So PTS is right here, and SRQ is right there. Are they opposite angles? This is going to be false. These are not opposite angles. Okay, if they're going to be opposite angles, then their arcs should cover the whole circle with no overlap. So this guy's arc, the green one, goes like this. And the blue one's arc would go like this. And those have overlap. They do cover the whole circle, but they overlap. So PTS and SRP are supplementary. So PTS is here, and SRP is here. Okay, so let's draw their corresponding arcs. So the green one's arc is here, and the blue one's arc is here, and they cover the whole circle with no overlap. So the total for the arcs would be 360. So that means the total for the inscribed angles would be half of that, which is 180, which means these two guys are supplementary. All right, let's flip it over and check out page 3. Problem 2, using corollaries to find angle measures. So in the diagram at the right, what is the measure of each angled numbered angle? So we have 4 of them in there, so we have to find them all out. So the measure of angle 4, which is this one, okay, is going to equal to half of its arc that it's related to. So this is an inscribed angle, and its arc that is with it is this green one. So we're going to have half of 60 plus 80. The arc that it's related to is the 60 and the 80 put together. So that's going to be half of 140, which would be 70. Okay. Circle the corollary you can use to help you find the measure of angle 2. So let's see. There's a quadrilateral formed in here. Okay, we can see it really easy. And angle 4 and angle 2 are opposite of each other. Therefore, since they're both inscribed angles in the same circle, then they are going to be supplementary of each other. Okay, so the opposite angles of a quadrilateral inscribed in a circle are supplementary. That's what we're going to use to help us. Therefore, the measure of angle 2 is going to equal to 110, and let's see why. So the measure of angle 2 plus the measure of angle 4 should be 180 because they're supplementary. And then we can put 70 in here for angle 2. I'm sorry, 70 in here for angle 4. And then solve for angle 2. And when we solve that, we're going to get 110. All right. Underline the correct word to complete each sentence. So the dashed line is a diameter. It goes all the way across, not halfway. So it's a chord. Okay. And circle the corollary you can use to help you find a measure of angle 1 and angle 3. So an inscribed angle in a semicircle is a right angle. We're not going to use the same one we used earlier. Okay. So angle 1 here is inscribed where this arc, okay, is half of the circle, so 180. So since the arc is 180, angle 1 is going to be 90, and the same thing is going to happen with angle 3. So angle 1 will be 90, and angle 3 will be 90, okay? And that means I have all of my measures now. So 1 is 90, 2 was 110, 3 was 90, and 4 was 70. All right, on the bottom here we have one more theorem. Theorem 12-12. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. All right, so we have the measure of angle C in this picture. So this is C. C is formed by a tangent line, okay? And then this chord right here will form angle C, right there. And that's going to be equal to 1/2 of the measure of BDC, that arc. So the arc that begins at the vertex, the tangent point of tangent C, and ends at the other side. Okay, it's going to be half as much. All right, so suppose the measure of angle C is equal to 50. Okay, then the measure of arc BDC would equal to 2 times the measure of angle C, which would be 100. Suppose the measure of angle BDC, so now we're using the other arc over here, okay, is equal to 80. So the measure of arc BDC is 80. That's certainly not drawn to scale, is it? So the measure of angle C is going to be equal to 1/2 of that, which would be 40. Okay. In the diagram at the right, so this one over here, okay, BC is tangent to circle O at point B. So there's our point of tangency. So we know we have a right angle here. The measure of angle ADB, arc ADB. So we want to know what arc ADB is. So this arc that goes with it. Okay. So if the angle is 90, the arc is going to be twice as much, so it would be 180. Okay, so what is the measure of angle ABC? That one's going to be 90. Okay, we used that to get our arc just a second ago. And that's because a tangent point, when a line of tangency to a circle, is going to form a right angle at the point of tangency. All right, let's flip it over and look at our last page. Okay, so before we do the last page, let's take a look at what that last theorem said. Okay, so here is a line of tangency, a tangent line CB. The point of tangency is at B. And I've constructed an arc, okay, using ADB, so you can see it in blue here. Okay, and then we have the angle ABC that's formed with the line of tangency and the chord that makes that arc. Okay, so notice where I put the chord, where I put the arc, the blue part, or the chord, the AB here, that the measure of the arc is always twice as big as this angle ABC. Okay, so if I move it around, okay, the arc is inside of the angle. So we're using the angle A, or arc ADB, the one that's inside of the angle. And that arc inside the angle is always going to be twice as big as the angle itself. Now, if you think about it coming from the other side, like maybe the angle was over here, CBA like this, then we'd be using this light green part as the arc, okay? And I didn't draw that one out to measure, so we can only measure from this side. But we always want to be talking about the arc that's inside the angle when we're using this theorem. So our angle goes ABC, the arc inside it is this dark blue arc, and the measure of the dark blue arc is always twice as big as the measure of the angle itself. And the angle is formed by the line of tangency and the chord that relates to that arc. All right, so that can help you, hopefully help you visualize this a little bit better. All right, on our last page here, we have problem number 3, finding arc measure. So in the diagram at the right, KJ is tangent to circle O. So this is a line of tangency right here. And there's our point of tangency at J. Okay, so circle the arc intercepted by J, QL. So here is J, Q, L. Okay, and we're going to circle the arc that's intercepted by this. This would be arc JL, because arc JL is being intercepted by that angle. Okay, by the inscribed angle theorem, then the measure of arc JL should be equal to 2 times the measure of the inscribed angle. So 2 times 35 would give us 70 degrees. Okay, so we know that that arc is 70 degrees. And then by theorem 12-12, X here, okay, so this X that's inside of there uses this same arc. We knew the arc already was 70, and that arc is inside of our angle KJL. Okay, so this arc is, X is going to be, the measure of the angle is going to be equal to 1/2 the measure of our arc. And our arc we already found to be 70, so this measure angle is going to be 35 also. So the value of X is going to be 35. And then we underline the correct words to complete each sentence. So QL is a diameter of this circle. So the measure of angle, also angle QJL is going to be a right angle. Okay, so this guy is a diameter. So its arc would be 180, and that means the angle for the inscribed angle here that corresponds with the arc and the chord is going to be 90, half as much. Okay, So use the justifications at the right to complete each statement. So the measure of angle QJL plus JLQ plus LQJ is 180. And that's because that forms a triangle in there. Okay. And then we're going to replace QJL with what we got for it up above. So the measure of QJL is going to be 90. That's what we just determined. And then JLQ was Y. That's this one right here that we don't know yet. Okay. And LQJ is going to be 35. That was given to us already. That's this one. So we had a 90, a 35, and an unknown Y in here. All right. So we can combine the 90 and 35 to make 125, and then subtract 125 to both sides of this to get 55 degrees for Y. All right, so that concludes our lesson. We have a little lesson check now. So as always, pause the video, try the lesson check yourself, and then come back. Welcome back. So a classmate says that the measure of angle A is 90 degrees. What is your classmate's error? Okay, so they see a diameter in here, and they go, oh, okay, so that means that's 90. But the problem is the diameter is one side of our angle. It's not the part that the angle inscribes into, okay? So it's not the corresponding chord that goes with our inscribed angle. So the diameter AC is a side of angle A. This is yes. It's not supposed to be though, okay? And then is angle A inscribed in a semicircle? This is no, it's not inscribed in a semicircle. The arc that it goes with is only that much, okay? So what is your classmate's error? So the error in thinking is the error in thinking is that an angle with a diameter as a side intercepts a semicircle, but that's not the case. Okay, so the measure of angle A is not going to be equal to 1/2 of 180, which they thought it was. Okay, it's going to be equal to 1/2 of whatever the measure of this arc is. All right, so that concludes our lesson for today. Check off the vocabulary words that you understand. So you should have inscribed angle and an intercepted arc that goes with it. So here is an inscribed angle, the angle that's inside of our circle. It has the vertex plus on the circle plus the two endpoints also on the circle. And then the intercepted arc that goes with it is the arc that's inside it, okay? And we learned that the measure of that arc is equal to 2 times the measure of whatever the angle was, okay? Or vice versa, half of the arc is equal to the measure of the angle. All right, so how well can you find the measure of inscribed angles? Hopefully you're in here, but we'll spend a lot of time practicing this in class next time. See you then.